All right, in this lesson, we're going to be doing some reflections of shapes. We're going to be reflecting shapes across the line y equals negative x, y equals x, the y-axis, and the x-axis. We're going to come up with some coordinate rules that would tell us how to change how the coordinates of a point change when they're reflected across any of these lines. And then we're going to apply those rules to some sample problems here on the back side. Again, I'm going to use, I'm probably just going to use a single color here. I'm going to use a pen. I would recommend you use a pencil in case you make a mistake. All right, so first of all, the line y equals negative x. In this case, the line y equals negative x is the collection of all the points in the coordinate plane where the y-coordinate is the same as the opposite of the x-coordinate. So, for example, 1 and negative 1. Or, say, 2 and negative 2. Or, say, I don't know, negative 4 and positive 4. And it just so happens that all of these points form a line that cuts diagonally, and I'm going to use kind of a dotted line here, diagonally through the coordinate plane at a 45-degree angle downward, cutting through the origin. So we're going to reflect this shape across that line. And what we're going to do is we have to count how many spaces each point is from the line, and its reflection appears that many spaces away on the other side. So L is 1.5 diagonals. Notice not 1.5 spaces or 1.5 units, because units would be traveling horizontally or vertically along the grid lines, and this is cutting diagonally across, which is the square root of 2 units. So it's 1.5 times the square root of 2, but just for simplicity's sake, we'll call it 1.5 diagonals. So its reflection will be 1.5 diagonals on the other side. So this is going to be L prime. G prime is 1, 2, 3.5 away. So its reflection will be, there's the half, 1, 2, 3 on the other side over here. So this will be G prime. And over here we have Q, and that's 1.5. So half and 1, and this will be Q prime. I'm going to go ahead and connect them here to make our new shape. And here is what this shape looks like reflected on the other side. Next door here, you've got the reflection across the line y equals x. Well, the line y equals x is the collection of all the coordinates that have x and y coordinates that are the same. So, for example, 1, 1, 2, 2, negative 5, negative 5, anything like that. Well, it turns out this happens to form a line that cuts diagonally, again, just like y equals negative x, but it cuts at a 45-degree angle going upward through the origin. And we're going to do the same kind of thing. We're going to count how many sort of diagonal spaces, the distance from L straight to this line, and then its reflection will be on the other side. That'll be L prime. And U, just count the diagonals, and its reflection will be that far on the other side. That'll be U prime. And then X, just count the diagonals, and then its reflection will be that far on the other side. All right, so I'm going to leave you to do that one on your own. Down here, we've got reflection across the y-axis. So the y-axis is labeled here. It's the vertical axis. And so all we're going to do here is we just count spaces, just like before, except in this case it's actual whole spaces. So T would be 1, 2, 3, 4 spaces from the y-axis, so its reflection will be 1, 2, 3, 4 spaces on the other side. That's T prime. I will be 1, 2, 3, 4, 5 spaces from the y-axis, so its reflection will be 5 spaces on the other side. That's I prime. Y is right on the axis, so it's 0 spaces from the axis, and so its reflection is also 0 spaces from the axis. And so there's our reflected triangle. Looks the same as the other one, just, well, reflected. Over here, for reflection across the x-axis, we're reflecting across this vertical axis right here, or sorry, horizontal axis, that's the x-axis. So it's the same deal. You just see how far each point is. How far is D from the axis? Well, its reflection will be that far on the other side. How far is P from the axis? Well, its reflection will be that far on the other side. In this case, the two shapes are going to end up overlapping a little bit. And again, I'll leave you to do that one on your own.